Can you solve this math challenge? Here's the question. Solve for the integer values of x, y, and z that satisfies this equation 3 raised to x plus 3 raised to y plus 3 raised to z equals 837. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal here is to solve for the integer value of x, y, and z given that satisfies this equation 3 raised to x plus 3 raised to y plus 3 raised to z equals 837. There's a lot of ways to answer this kind of question, but instead of using algebraic approach, we will use different thing. We will use number bases. Now, why we do that, or why we choose number bases? Because take note, on the left hand side we have 3 raised to x plus 3 raised to y plus 3 raised to z. It looks like that the number on the left hand side is in base 3. So on the right hand side, take note that 837 is in decimal form or in base 10. So what we're going to do here is we take this 837 and then let's focus on this number and convert this number into base 3. The reason is, again, on the left hand side of our equation 3 raised to x plus 3 raised to y plus 3 raised to z, this number is indefinitely in base 3. So let's convert 837 in base 3. Now, the question is how to convert 837 in base 10 to base 3. Here's the easiest way to convert this number, or in that decimal number, to base 3. First, let's get this number and divide it by 3. So 837 divided by 3, get the quotient and get the remainder. So 837 divided by 3 will give us 729 remainder of 0. This remainder is very important later on. The next step is to get the quotient 729, and then after getting the quotient 729, what we're going to do here is to divide 729 by 3, get the quotient and get the remainder. So 729 divided by 3 will give us 93 remainder of 0. Now let's repeat the process. Get the quotient 93. Then what we're going to do here is to divide this 93 by 3, get the quotient and get the remainder. 93 divided by 3 will give us 31 remainder of 0. Again, let's get the quotient 31. Divide the quotient by 3, get the quotient and get the remainder. 31 divided by 3 equals 10, remainder of 1. Again, let's repeat the process. Get the quotient of 10. Divide this 10 by 3, get the quotient and the remainder. We get 10 divided by 3 will give us 3, remainder of 1. Again, let's repeat. Get the quotient of 3. Divide this 3 by 3. Then get the quotient and the remainder. 3 divided by 3 will give us 1, remainder of 0. 1 last time. Take this 1, the quotient, divide this by 3. This will give us a quotient of 0, then remainder of 1. Now we will stop at this point because the quotient now is equal to 0. Now take note, we will stop if we get the quotient equal to 0. Now at this point, let's focus on the remainders. So from the bottom to up, so we have 1, 0, 1, 1, 0, 0, 0. So to convert 837 to base 3, what we're going to do is to consider the remainder from the bottom part up to all the way up to this top remainder, or the first remainder, which is 0. So 837 in base 10, in base 3, it is equivalent to just 1, 0, 1, 1, 0, 0, 0. So let's focus now on this number. 837 must be equivalent to 1, 0, 1, 1, 0, 0, 0 in base 3. Now what does it mean? 837 must be equivalent to 0 times 3 raised to 0 plus 0 times 3 raised to 1 plus 0 times 3 raised to 2 plus 1 times 3 raised to 3 plus 1 times 3 raised to 4 plus 0 times 3 raised to 5 plus 1 times 3 raised to the 6th power. So, take note that a lot of numbers is just 0. For example, 0 times 3 raised to the 5th power is just 0. 0 times 3 squared is just 0. 0 times 3 to the 1 is 0. And 0 times 3 raised to 0 is also 0. So let's eliminate all of these terms. This will leave us 1 times 3 raised to 6 plus 1 times 3 raised to the 4th power plus 1 times 3 raised to 3. And if we simplify this more, this is simply equivalent to 3 raised to 6 plus 3 raised to the 4th power plus 3 raised to 3. And now take note that 3 raised to 6 plus 3 raised to 4 plus 3 raised to 3 is simply equivalent to 837. Therefore, we can equate 3 raised to x plus 3 raised to y plus 3 raised to z to 3 raised to 6 plus 3 raised to 4 plus 3 raised to 3, like this. At this point, we can now easily get the values of x, y, and z. Take note that x can be 6, y can be 4, and z can be 3. But take note, if we rearrange some terms a little bit, now x becomes 4, y becomes 6, and z becomes 3. Also, we have a lot of configurations, or in mathematics, this is called permutation. So our answer to this question, the integer value of x, y, and z given this equation must be equivalent to 6, 4, or 3, and its permutation. Therefore, our answer to this question, what is the integer value of x, y, and z that satisfies this equation 3 raised to x plus 3 raised to y plus 3 raised to z equals 837, and our answer is 6, 4, 3, and its permutation. And as always, we are done.